A symmetric bioconvex lens of radius of curvature r and made of glass of refractive index 1.5 is placed on a layer of liquid placed on top of a plane mirror as shown in the figure. An optical needle with its tip on the principal axis of the lens is moved along the axis until its rear inverted image coincides with the needle itself. The distance of the needle from the lens is measured to be x. On removing the liquid layer and repeating the experiment, the distance is found to be y. Obtain the expression for the refractive index of liquid in terms of x and y. Okay, now here we need to find the refractive index of liquid in terms of x and y. That means here the two different cases is there. One convex mirror they are going to play, one convex lens they are going to place on the mirror. When the light is passes in this direction, then when it reaches here, it will comes to the normal like this, and it will reflect and go back in this direction. And in the same way, in the another direction also, if it is the light will be passes, so it will come like this. And when it reaches here, it will go normal to the mirror, and the reflection goes like this. And the distance, the total distance, now we can see this is a concave. So this is a concave mirror, and the total distance from the mirror, concave mirror and the convex, the total distance is x. This distance is equal to x when liquid is present. That means in between the convex and the mirror, a liquid is present. Now here by this time we need to find here the refractive index, that is mu L. And if this liquid is not there, then the air is present. That means if I am going to the same diagram, assume that here the mirror, this is the mirror. Over the mirror, if I am going to place the convex lens, then the focal length, here, this focal length will become y. When instead of liquid, if air is there, then I am going to write it as mu g. Okay, now we need to find the value of this mu L. That is the work. Okay. Now, when convex mirror is there, we have two different radius. Assume this is a convex mirror. We have two different radius. One radius is like this. We call this is a R1. It is in the positive. And this radius, it is a R2. And it is a negative radius. Okay. Moving in the clockwise direction as well as in the anti-clockwise direction. Now, we know that when the image of the needle coincides with the lens itself, its distance from the lens equal to the relevant focal length. With liquid layer present, the given setup is equivalent to a combination of the given convex lens and a concave plane liquid lens. Then we have to find here the equation for this one. The total focal length. First I am going to take without liquid. If I am going to take this one, then total focal length F is equal to the total distance is y. Okay. Then 1 upon F is equal to refractive index of this one, that is mu g minus 1 into 1 upon R1 minus 1 upon R2, where R1 is the positive, or where R1 is the positive, I would take this R1 is equal to positive R, and R2 is equal to, it is negative, that is minus R. When I am going to substitute here, then 1 upon F is equal to, mu g value we know that it is 1.5 minus 1 into 1 by R minus of 1 by minus R. When we simplify, we will get the value that 1 upon y is equal to 1.5 minus 1 is equal to 0.5 times of 2 divided by r. Then we can say this one as 1 by y is equal to 1 by r, or we can say y is equal to r. This is very, very important. We need to take next level. Okay. Now, if it is total length, if it is the total length, then this becomes 1 upon FL, total focal length, FL is equal to, when liquid is present, mu L minus 1 into same, that is 1 upon R1 minus 1 upon R2. In this case, this R2 will become the infinity length. Then we can substitute as 1 upon FL is equal to mu L minus 1 into 1 upon R1 is the, that is minus R minus of 1 upon infinity. 1 upon infinity is equal to 0. Then 1 upon FL is equal to minus R divided by mu L minus 1. We know that R is equal to Y. Then I want to substitute here 1 upon FL is equal to minus Y divided by mu L minus 1. Then the total focal length, then I'm going to write this one as 1 upon capital F is equal to 1 upon F plus 1 upon FL. We know the value now. Total length, they are going to give us, that is concave and convex length is equal to x. That is 1 upon x is equal to 1 by f is equal to 1 by y plus mu L minus 1 divided by minus y. Then 1 upon x is equal to 1 upon y minus mu L divided by y plus 1 by y. Then mu L by y is equal to 2 divided by y minus 1 by x. Then mu L is equal to 2 minus y by x. This is the expression for the refractive index, that is mu L of liquid in terms of x and y.